Hello, welcome to Formtek's podcast. My name is Brian. We're going to talk a little bit today about the different types of press styles used in the roll forming process for pre-notching and cutoffs. Today I have Paul Williams and Darren Muchnicki with us. We're going to discuss these topics and see how we can proceed. So, Paul, why don't you give us a rundown of the different types of presses out there that we use in the roll forming industry?
Sure. So typically, there's three styles of presses that we would typically use on a roll forming line. One is air/pneumatic presses. Second one is hydraulic, or third is mechanical presses.
Okay.
And each in those three categories, there's different style of presses. In the air pneumatic, a very common style of press is a bladder style press where there's a bladder in between the top plate and the movable ram. Or it would be where you mount an air cylinder to the top of the ram, or as an underdriven gets pulled down from underneath. Hydraulic, same way. Hydraulic cylinder could be on the top, could be on the bottom. And then mechanical presses could be where they have a mechanical crank, and the crank could be on the bottom, which is a underdriven press, which is a very popular press in the roll forming industry. Mm-hmm. Or mechanical press that you would see in a regular stamping operation with a lot of OEM manufacturers.
That they've adapted over
Absolutely,
into the roll
right.
forming
Just
process.
so we use
so you can still use some of the big name
absolutely
mechanical presses.
And we do as well, especially in the pre-punching system.
Okay. So when would a customer consider one over the other, or why would they consider one over the other?
So typically air presses are the most economical type presses for the type of tonnage you can get out of those.
Okay.
So as of a lower cost type of scenario, an air press is the most economical way. A downside to air presses is that depending on if they're in the case of a bladder style press, their tonnage rating is at 100 psi at a half-inch stroke. So most bladder presses can go about 3 inches of stroke. More stroke on a bladder press, less tonnage you get. Okay, so if you have something where you have a blade type cutoff die where you have multiple strokes, inch and a half or 2 inch stroke, just because you have a 20-ton press, you're not actually getting 20 tons. Okay, if you use an air cylinder type for that, you may not be able to get that much tonnage out of that cylinder. Okay, so with any type of cylinder, hydraulic or air, you'll tend to get the full tonnage all the way through the stroke, but now you have a really big cylinder that you may not be able to actually do. Right. Okay, hydraulic presses, there's a couple different styles. We call them HHP, which looks like an air press, but just has an hydraulic cylinder on there. And we also have an HX series, okay, which is where we mount a cylinder on a die, and this way we can do all kinds of different things. Custom work, because the cylinder doesn't care which way we cut things, up, down, left, right, anything like that. So typically HHP press is maybe about double of an air press in the same tonnage range, okay, if everything's apples to apples. When we get to the mechanical presses, the underdriven presses are fairly expensive, okay, compared to an air press, and maybe a little bit more than our HHP standard hydraulic presses. And then when you get into the regular OEM mechanical presses type things, those can be somewhat cost effective, especially for pre-punching, for the bed size and that you need, and the strokes per minute. So it comes down to combination of some tonnage, the application we're doing. There are certain applications we wouldn't want to do in an air press that we need to do in a mechanical press or a hydraulic.
Like what?
So cutting any kind of forming. Right. Okay, so any kind of forming, cut off and form or emboss, we don't want to do that in an air press, okay, because even though there's typically ram stops, you don't want to bottom one of those presses out, okay, type of thing. And the speed of an air press is so fast that it could cause some issues in regards to some of that forming. So if it was a cutoff and form where we're going to go ahead and form up the tail and legs,
tabs or something,
so we don't have to go into a secondary operation, we just take care of it all in the cutoff. We'll look at a hydraulic press, self-contained hydraulic press, or a mechanical press.
Okay. So Darren, Formtek has several different types of mechanical presses that we build, different tonnages, I should say. They all seem to be what we call an underslung driven press. Why is that? Why did Yoder many years ago or Tishkin many years ago develop these underslung presses, which are really only used in the roll forming industry?
Yeah, they're primarily because they were quick. They were short stroke. The most stroke we have is a 6-inch on a higher tonnage, but for a 50-ton press, it was either a 2-inch or a 5-inch stroke, or a 2-inch and 4-inch stroke, depending on what crank you had in there. So it was quick. But we don't run these presses continuous. They run single stroke. So sure, we put a very good quality clutch and brake on it, but again, they're single stroked. If you have and they were fast enough, they would give you a good enough cut. And like Paul said, if you had to do a form or something in the end, you could still do it. And that was before. Those were created well before hydraulic presses were around.
Absolutely.
So that was the only way you could do it. So it was only hydraulic, and really air didn't really come into play until about the sometime in the late 70s, early 80s is about when air was around, if I remember correctly. So it was really just mechanical presses, and those were it for the roll form application. Now, do people use like a stamping press for a cutoff? Sure, you can do that, and most time they'll do it just because of bed length, or if they're going to put some extra, like do a die train, so they're punching a bunch of extra things right in the cutoff and back up the part. They'll do that.
Or they had one sitting in the corner.
But if you have is an underslung press, can you use it as a pre-notch press? You can, but it's at that point you'd really look at a stamping press, especially if you're going to run it continuous.
It's a little overkill.
It wants to run continuous, right? A stamping press wants to run continuous. It's thinking of a prog die. It just wants, sure, somebody would push you can do palm buttons and you can single stroke them, but you just want to run. They want to run continuous, and there's applications for it. Again, application based.
Right. Now, Paul, with when we're talking air or pneumatic presses and we have hydraulic presses, when we sell a system like that, the hydraulic obviously comes with its own hydraulic power pack. Mm-hmm. But with air, the customer has to have some type of device making the air. And is that usually part of somebody's decision on buying? Because they got to, if you think about it, it's stroking a lot through the day. You have to have a fairly large air compressor.
So in some cases, especially typically we'll go up to about 30 tons in an air press. Anything larger, well, you could do that with multiple bladders and things like that. The air consumption, especially the amount of stroke that you use, could be quite large and may require a customer to go ahead and buy a separate system.
I remember the one customer had a 300-ton air pre-notch press, and they had, I think it was about 6-inch pipe full of air going into it.
That has to be pretty costly.
But it was costly.
It was costly. And I've seen 100-ton presses, air presses, that
they're
are just loud, violent. But some of that goes into how they're set up. So going to the question, so typically, going to that, we provide a little bit of how much cubic feet that the bladders will generate depending on the stroke, so they can have some kind of information to figure out if their current system in the plant will work that, or if they need a separate system. When it comes to the air presses, as Darren alluded to, the noise. And typically, what I found over all the years is that most of the time the presses weren't sized correctly for tonnage for the application. So just because you have a 20-ton press, as I mentioned, their ratings on a bladder style press, let's say, are half-inch, 100 psi, half-inch stroke. Oh, I have 20 tons. And this goes to a general statement of any process. Oh, let's throw something in that requires 20 tons. Well, it's not going to work well, right? So typically they have the air presses sized wrong. And then with especially a bladder style press, the thought is that you want to go ahead and you have the bladder, you send a signal, the bladder expands, it sends the ram down, okay? But you want to shut the air off. A lot of people have the air, no matter what PSI, going full bore all the way down to the ram stops. So all of a sudden you're just getting a pow, 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 right? Because it's hitting the stops, air going full bore. We actually want to shut that air off, use the inertia of the ram to go ahead and finish the cut,
Well,
Okay.
what brings the ram back up?
So we got there in the bladder style presses, there are springs, basically die springs that are bringing it back up to the home position there.
So you're expanding, when you expand the bladder, it stretches the springs. You turn it off, the springs bring the ram back up.
Right, and we'll turn the air off two different ways, using the electronics in their measuring system, whatever. And even if we do have that, we still put in the old micro switch with a threaded rod with a couple of washers that just shuts off the air as well as a double check. The other thing is regards to tonnage, a lot of it just comes down to that of figuring out the right application that the OEM should be able to figure out.
Yeah, I think that's a good statement with the tonnage, because that really, like you said, applies to all the presses. You want to give yourself a little bit of extra room. You don't want to if your application needs 70 tons, you don't want a 70 or an 80 ton press. You probably want a 100-ton press, so you have some ability to either grow, or you have other things with the die, dullness.
Sure.
And those types of things.
So a typical rule of thumb when I'm looking at tonnages that we're looking to size, and it works most of the time. There are definitely situations where like this calculation doesn't work, but as soon as a die punches or cuts, it starts to get dull. Mm-hmm. So dullness can add 10 to 30% of your tonnage reading. So let's say for simple math, we have a 100-ton situation. So now at some point we're going to add 10 to 30 tons. So now my 100 tons is 110 or 130 tons.
Right. So you have to have some room.
At least there. And then typically your OEM manufacturers of mechanical presses state that they want to have use only 75% of the tonnage of that press. Okay. Now that is sometimes that's unreasonable. You just can't do that. But if you take that theory, okay, of 10 to 30% and using 75% of a press tonnage, okay? So if we have a 100-ton press, we only want to use 75, all right? So typically what I do is I calculate a tonnage, and I'll add up to 55% to that tonnage. That takes care of 30% dullness, which also can take care of some bad materials. All of a sudden, a buyer found a deal on some higher tensile yields, something like that, and all of a sudden now we run into problems with tonnage. And then we're only using X amount of the 75% of the tonnage of the press. Once again, that's a nice initial rule of thumb, and that way, especially on an air press, you're not running at 100 psi. You're running at maybe 50 psi, and that helps in that. And also gives you a little extra room of stuff. Now, once again, on some higher tonnage applications, that's not a good. We would be in a 500-ton mechanical press for a pre-notch system, and that's unreasonable, right? So we have to look at different things to be able to do that.
But how many times have we found out where operators have turned up the air pressure or the hydraulic pressure because they weren't cutting through, and they just go ahead and they crank it up, thinking that, oh, I need more tonnage, and it really is just a case where the die is dull.
Absolutely, and air press, that's easy to do.
And
the hydraulics you can do that, but there's a lot of check valves and stuff will happen if you go over too much of that pressure of what it was designed for in our systems. Mm-hmm. Now you basically could be damaging the system.
Right, and even with a mechanical press, some people, they'll say, because it's set, it's mechanical, right? It's a fixed distance to cut through something, and it's cutting through. It's been cutting through this part for 3 years, and I've never had a problem. And then one day, I'm not cutting all the way through. So what do? They go ahead and they'll put a shim in there between the die and the ram, thinking that they got to come down further. And then what do? They end up blowing the die apart, and the die just needed to be sharpened. Yeah. So because it's a fixed distance.
Well, and after 3 years, you would think so, but how many times have we heard that, right?
Oh, I haven't sharpened that die in 5 years.
Well, it's just like any other cutting device.
Right,
it gets dull, you have to do something.
It's like anything, you got to take care of the stuff. You got to take care of your equipment.
And so some of it comes along with the mechanical presses as well, as we touch base on the air presses, but the tonnage and things like that. Some people don't realize mechanical presses have a tonnage rating. Okay, so a 100-ton press, their tonnage rating may be 1/16 from the bottom of the stroke, okay, or maybe up to a 1/4 inch to the bottom stroke. It depends on the manufacturer, the type of crank, dual geared, things like that.
So you actually have to consider that in your die design of when you're going to start impacting the material, and it actually cut all the way through, and you have to compare that to the specifications of the mechanical press.
Absolutely, and that's
And
the
you
same.
trick it though sometimes because you put stagger in there, you
Well,
can put shear in there, but you
well-
can only do it to a certain
Well,
degree.
so stagger doesn't help with tonnage because you take energy away from the press.
Correct.
That's a whole nother discussion of mathematics stuff, like, you know. But we're not going there. but anyway, but on the underdriven mechanical presses, there's the same problem of that tonnage rating. So to your point of on a material, a lot of times as a safety factor, you're on a punching die system, you want to enter 1.5 the material thickness. That's overkill, okay, but that's a nice number. So you take that number, if you have a 100 thousandths material, let's say, I'm just using for simple numbers, 1.5 materials, we're actually entering 150 thousandths then into the die block, okay, the punch. Well then, so I'm 150, past the bottom of the material plus 100,000. So now I'm impacting the material 250 thousandths above the bottom of the stroke. If
Right.
my tonnage is rated at 16, I'm not at full tonnage,
Right.
right? And so that comes into play, and it's even on the cutoff dies and stuff like that, blade type dies, same thing. When we're impacting so high on a tube or a deep section with a slug type die, that comes into play as well.
Yeah. I think one thing we haven't touched on, and we should before we wrap up, is the advantage of hydraulics. I mean, hydraulics really came into play late 80s, early 90s is when that all started because of customizable, but the biggest advantage of hydraulic is it's full tonnage through the entire stroke.
Absolutely. So now we're not worried about issues of in a bladder style press where we have whatever that bladder, we go 1 inch, 2 inch, 3 inch, we lose tonnage. Mechanical press, this tonnage rating thing.
Based on the bottom dead center
Center,
and
yep.
location.
Now you have it all the
Hydraulic, we
way.
have it all the way through.
Absolutely. And the beautiful thing about the hydraulics is now that it allows us, the cylinder does not care how we're going to mount this. Okay. So we can come horizontal. We can come in through an angle like we do our step beam cutoffs now, where we eliminate pre-punching because what's the strongest part through a roll, strongest area through a roll form part is through the radius. So now we set the cutting angle coming through a radius, type of scenario. So while the HX series, where we mount the cylinder any which way, is more expensive than our HHP product, which is a 4-post type of press, gives us a lot of flexibility on doing all kinds of unique things.
And it helps with minimizing burn things on the product.
Why are you doing the unique things? I mean, you're doing unique things to save secondary operations, right? And trying to do as much complete off the line as you can.
Absolutely, or saving the step beam that doesn't have any other features. Now we just eliminate a whole pre-punch process.
Right, you saved a bunch of money, right? So you may save some, spend a little more here, but you're going to save all this other equipment that you got to
Yep.
maintain and
Which is the whole purpose of the roll forming
Correct.
line anyway.
Right, well,
You're
another
trying
thing
to do as
too
many things as you can.
is with the HX series. So how many systems that we put together now would allow us where we have a roll former, and then depending on mechanical press or underdriven press or an air press, that's separated from the mill. Well, how many of those systems now what we call rafted systems in the HX series, where we put the cutoff die on the mill, a self-contained slugless die or something. Now they're really close to the straightener, everything else. So when you're further away from that straightener and you get some up bow, down bow, twist or something like that, trying to get that through a die sometimes can be difficult. Well, now the closer we can get to that straightener, that helps with that overall setup as well. So it gives us some flexibility of decreasing an overall line
but
space.
again, but you're not going to get into huge tonnage hydraulically though.
No.
So there's certain, if you're pre-notching a lot, I doubt you're going to do it hydraulically. You're probably going to do it mechanically because it's economical, and it's easy for someone to do. But if you're going to get into post punch, inline, or cut off, and something unique that you got to come, like he said, come from the side, or even come from the bottom. We've come from the bottom.
Yeah.
We've cut up.
Yeah, just slow down. But going just to the point there, while we were talking a little bit about pre-punching and with mechanical presses, the key to all that, and it comes down to throughput, is we want to have the mechanical presses running in a continuous mode because their ratings their strokes per minute are based off of running continuous. Okay.
For the commercial presses.
For the commercial presses, right. And so Because when you just single stroke the press, like Darren mentioned with the underslung presses, you can start to wear out the clutch and brakes on those things. But they could be easily half of what the strokes per minute is. So if you have 100 strokes per minute press and you're single stroking, you could be 30 to 50 strokes per minute. So now you're not going to get the throughput.
So one of the disadvantages of a lot of people say of hydraulics is you can't get the strokes per minute that you can get from your mechanical press. Is that a true statement? Or, I mean, theoretically, you would almost think that if you could put a monstrously large hydraulic unit to back this press, it could cycle incredibly fast forever.
Absolutely. It's only money.
So especially
it costs
shorter strokes.
Yeah, and so typically we'll look, generally when we're looking to size a hydraulic system, easily 60 strokes a minute on a cutoff system.
With a shorter stroke.
Oh no, it could be even longer stroke, depending on the tonnage. Okay, and the reason why we do that as an open loop system is that usually we figure a quarter second up and down cycle time. Okay, and then that gives us 0.75 seconds of hydraulic dwell to recharge the system. But we know typically in that amount of time we can fly out and get back home to hit the next part. Now we can go more strokes per minute, and we've done that, okay? But it comes into, like we were talking about the air presses and stuff, it comes down to a cost factor. So while we could do that in a punching system, a pre-punch system, and go faster strokes, it really isn't cost effective to do that. And then especially if we need a larger bed or things like that, the commercial mechanical presses out there give a lot of versatility of what we can do between stroke per minute, bolster sizes, things like that.
What about, so we talked a little bit about some of the disadvantages of pneumatic in terms of it's loud. It can be loud. It can be loud if they're not always fine tuning the pressures. And that can really happen a little bit in hydraulic as well.
Absolutely.
You can turn the pressure down, so to speak. What about maintenance? Hydraulics, is it harder to maintain? I mean, you always see the filters on the hydraulic unit. Is it just as simple as changing that filter out?
Most of the time, if you're doing a continual PM process with that, you're just changing the filters.
How long does the oil? Is it a yearly thing to change out? Is it every 2 years? Is it every 4 months? Or
that's a great question. It could vary depending on the application. How much we're stroking? How much is it used? Is it used?
Probably the
7
reservoir
days,
size,
right? Everything like that. So, I mean, easily, every few months to change out the filters in general. Okay, the more you do that, right? If you change it every week, it's going to be a better scenario, right? Because you're taking out your contaminants and anything else that happen to get in there. So.
Okay. What about mechanical presses? I mean, other than we talked about the bottom dead center and
it's just really
calculated
clutch.
things.
It's your clutch
It's
and
your
brake.
clutch and brake.
And making sure you do the normal PM, grease your head rods and all that. But it's mostly it's taking care of the loop points and clutch and brake. But there's units that have been running out there for 25 years and people haven't touched them.
Yeah, easily.
Just depends on how you're using it.
Yeah. I'd say with the air press, bladder style presses, or even our air cylinder ones, and or the HHP presses, it's just lubing up the bushing of the pins and just things like that. Just some just doing some normal PMs, preventive maintenance things goes a long way. All of a sudden, there's stuff that's still been running. We could call it like 20 plus years of our hydraulic systems, that never heard anything and said, hey, this is just starting to go bad now. Well, after that long time, that's great,
All right.
Good to know.
All right. Well, thank you, gentlemen. Please join us for our next podcast, and feel free to visit our website, formtekgroup.com. Thank you very much.